Welcome to McDonald's. My name is Bill. How may I help you today? That'll be 816 at your first window. The learning target for today is to be able to create and use frequency tables and histograms. The scale, you're 3 if you can create and use frequency tables and histograms. 2 if you can create and use frequency tables or histograms. 1 if you can create or use frequency tables or histograms. And you're 0 if you cannot create or use frequency tables or histograms. As a note, if you can create or use both frequency tables or histograms, you're still a 1. Please remember at the end of the video, go back to the beginning and on the top of your page, put where you are on your scale. Chapter 2, Organizing Data. Section 2.1, Frequency Distributions, Histograms, and Related Topics. Alright, so here are the focus points for the lesson. First, you're going to organize raw data using a frequency table. You're going to construct histograms, relative frequency histograms, and ogives. You're going to recognize basic distribution shapes, uniform, symmetric, skewed, and bimodal, and interpret graphs in the context of the data setting. Frequency tables. When we have a large set of quantitative data, it's useful to organize it into smaller intervals or classes and count how many data values fall into each class. A frequency table does just that. A frequency table partitions data into classes or intervals and shows how many data values are in each class. The classes or intervals are constructed so that each data value falls into exactly one class. First example, the task force to encourage carpooling did a study of one-way commuting distances of workers in the downtown Dallas area. A random sample of 60 of these workers was taken. The commuting distances of the workers in the sample are given in Table 2.1. Make a frequency table for these data. So I do want you to write down all this data here because it's going to come up a bunch of times in this video. So write that down. Example 1. So part A. First, decide how many classes you want. 5 to 15 classes are usually used. If you use fewer than 5 classes, you risk losing too much information. If you use more than 15 classes, the data might not be sufficiently summarized. Let's spread the data, and the purpose of the frequency table be your guides when selecting the number of classes. In the case of commuting data, let's use sits classes. Next, find the class width for the sits classes. How to find the class width? You just take the largest data value, subtract the smallest data value, and divide by how many classes you're going to have. If it's a number that's a decimal, always go to the next highest number. So if you have 3.1, bring that all the way up to 4. And even if you have a whole number, say you have 4, that would go to the next highest whole number, which would be 5. So always go up to the next highest. To find the class width for commuting data, we observe the largest distance commuted is 47 miles and the smallest is 1 mile. Using sits classes, the class width is 8, since 47 minus 1 divided by 6 is 7.7, and we increase that to 8. Now we determine the data range for each class. The lower class limit is the lowest data that can fit into a class. The upper class limit is the highest data value that can fit in a class. The class width is the difference between the lower class of one limit and the lower class of the next. The smallest commuting distance in our sample is 1 mile. We use the smallest data value as the lower class limit of the first class. Since the class width is 8, we add 8 to 1 to find that the lower class limit for the second class is 9. Following that pattern, we establish all the lower class limits. Then we fill in the upper class limits so that the classes span the entire range of the data. So if you see here, we started with 1 for the lower class limit, added 8 to that to get 9, added 8 to that to get 17, plus 8, 25, plus 8, 33, plus 8, 41. And then we went to the barriers of each. So right before 9 is 8, right before 17 is 16, and so on. And of course, the next one after 41 would be 49, but that's too high, so we just go to 48. Even though we didn't have a 48 in there, we still have our limit to 48. Now we'll talk about these other things in a moment, the class boundaries and the class midpoint, but the frequency is just how many ended up in your limits. But we'll talk about all those in a second. Now we are ready to tally the commuting distance data to the 6 classes and find the frequency for each. So to tally, all you do is just see how many are in that range and give a tally mark for each. The total tally you get is the class frequency. The center of each class is called the midpoint, or class mark. The midpoint is often used as a representative value of the entire class. The midpoint is found by adding the lower and upper class limits of one class and dividing by 2. So for one of them, the lower class limit was 1 and the upper class limit was 8. 1 plus 8 is 9. 9 divided by 2 is 4.5. So the midpoint, as you would have seen, is 4.5. There's a space between the upper limit of one class and the lower limit of the next class. The halfway points of these intervals are called class boundaries. These are shown in Table 2.2. All you do to find them is, for the upper class boundaries, add 0.5 to whatever your limit is, to your upper class limit, and for lower class, subtract 0.5 from the lower class limit. This allows you just to show that there's no overlap. What a lot would do would say that actually the limits from 1 to 9 and then 9 to 16, but anywhere up to 9 doesn't count in the first, and then if it's 9, it's in the next one. To do this, it just separates them by decimals, so we have a clear separation there. Basic frequency tables show how many data values fall into each class. It's also useful to know the relative frequency of a class. The relative frequency of a class is the proportion of all the data values that fall into that class. The relative frequency of a particular class, to find it, divide the class frequency f by the total of all frequencies n, which is the sample size. So if we have a frequency of 14 and there's a total of 60, we say 14 divided by 60, and we get 0.23, so that's the relative frequency. 23% of the data is in that class. Now here's relative frequency again with the table again. Since we already have the frequency table, the relative frequency table is obtained easily. The sample size is 60. Notice the sample size is the total of the frequencies, added all up. Therefore, the relative frequency for the first class from 1 to 8 is 0.23, as I mentioned. That symbol means about, approximately equal to. The total of the relative frequencies should be 1, but if you round it at all, it'll end up being slightly higher or lower than 1. So just a refresher, the procedure on how to make a frequency table. Determine the number of classes, create the classes with the lower limits, fill in the upper class limits, make a tally and get the class frequency, find the midpoint, and then figure out the boundaries. For a relative frequency table, first mate the frequency table, then for each class, compute the relative frequency, f divided by n, frequency divided by the sample size. Histograms and relative frequency histograms. Histograms and relative frequency histograms provide effective visual displays of data organized into frequency tables. In these graphs, we use bars to represent each class, where the width of the bar is the class width. For histograms, the height of the bar is the class frequency, whereas the relative frequency histograms, the height of the bar is the relative frequency of that class. How to make a histogram or relative frequency histogram. Step 1, make a frequency table. Step 2, place class boundaries on the horizontal axis and frequencies or relative frequencies on the vertical axis. Step 3, for each class of the frequency table, draw a bar whose width extends between corresponding class boundaries. For histograms, the height of each bar is the corresponding frequency. For the relative frequency histograms, the height of the bar is the relative frequency. So you take our table, the way we had it before, then make your frequency table that we've had before. Unless you're doing the relative frequency, then you use the frequency table. Then you make your histograms. On the left, we have the frequency histogram, and on the right we have the relative frequency histogram. So on the left, see from 0.5 to 8.5, that was the 1 to 8, there it goes up to about 14. So right here is about 14, and each one goes to where it was. Then notice the relative frequency histogram goes to the relative frequency. So this one, if I remember correctly, was 0.23, so right about here. And each one goes to the relative frequency it was. Notice that these are the same. Same graphs, just depending on what's in your y-axis, frequency or relative frequency. And as it says here, notice the basic shapes of the graph are the same. The only difference is the vertical axis. The vertical axis of the histogram shows frequency, where the relative frequency histogram shows the relative frequency, but same shape. Distribution shapes. Histograms are valuable and useful tools. If the raw data came from a random sample of population values, the histogram constructed from the sample values should have a distribution shape that is reasonably similar to that of the population. Several terms are commonly used to describe histograms and their associated population distributions. So, first we have mound-shaped symmetrical. Those are essentially, they make an upside-down U. Sometimes they're known as a bell curve. So those are pretty much symmetrical. If you were to put a line down the middle and reflect it over on top of itself, it would be the same. It's same on both the left and the right. Uniform or rectangular, those are where all the frequencies are exactly the same, and it just makes a rectangle. So no part of the histogram is bigger or smaller than any other part. For skewed left or skewed right, those are slightly different, but the same meaning. To be skewed is to have a tail at one side. So if it's skewed left, it has a bump towards the right, but a tail that's really low towards the left. And skewed right is the opposite. A bump on the left, where most of the data is, and where a little bit of the data is towards the right, making the tail. And the bimodal is where there's two bumps. So you've got a lot of data in two spots with a little data in between and on the sides. And here are some graphs. So the mound shape with a histogram, if you were to draw a line about what it would be about a U shape. you've got a lot of data in the middle and then less data on the sides. The uniform, again, makes a rectangle. Everything's the same. The skewed to the left, so you've got a lot of data on the right and it goes down as you go to the left, so it makes a tail. And skewed right is just the opposite. A lot of data on the left, and then it goes down towards the right, making a tail. Bimodal, got a lot of data in two spots, but less in the middle or the sides. Cumulative frequency tables and ogives. Sometimes we want to study cumulative totals instead of frequencies. Cumulative frequencies tell us how many data values are smaller than an upper class boundary. Once we have a frequency table, it is a fairly straightforward matter to add a column or cumulative frequencies. The cumulative frequency for a class is the sum of the frequencies for that class and all previous classes. An ogive is a graph that displays cumulative frequencies. How to make one? First, make a frequency table showing class boundaries and cumulative frequencies. So every time you find a frequency, you add it to all the previous. Number 2, for each class, make a dot over the upper class boundary at the height of the cumulative class frequency. The coordinates of the dots are upper class boundary, cumulative class frequency. Connect these dots with line segments, so it'll look kind of like a line graph. By convention, an ogive begins on the horizontal axis at the lower class boundary of the first class. So here's an example. Aspen, Colorado is a world-famous ski area. If the daily high temperature is above 40 degrees Fahrenheit, the surface of the snow tends to melt. It then freezes again at night. This can result in a snow crust that is icy. It also can increase avalanche danger. So we take this frequency table and see we have each of the frequencies here. The cumulative frequencies add each of the frequencies up. So first one is the same as the frequency. The next one is that frequency and the previous added. The next one is this frequency and the other two added. See 66 plus 51, because 51 plus the previous of the two before 66, and so on. And if there's 151 days in the ski season, the cumulative frequency for the last one should be the same, 151. So, part A, the cumulative frequency for a class is computed by adding the frequency of that class to frequencies of previous classes. To draw the corresponding ogive, we place a dot at the cumulative frequency 0 on the lower class boundary of the first class. Then we place dots over the upper class boundaries at the height of the cumulative class frequency for the corresponding class. And it should look like this. So lower boundary was 10.5, so we put it right at 0. Next one was 20.5, so it goes to the first cumulative frequency, 23. Then we had 66 for the next one, 117, 144, 151. Looking at the ogive, estimate the total number of days with a high temperature lower than or equal to 40 degrees Fahrenheit. Well, if you see 40 degrees Fahrenheit, this was 40.5, so the limit went to 40, so up there went to 117. So the answer's 117. So we see that there's 117 days have had high temperatures of no more than 40 degrees. Alright, now time for the sponge activity. So I want you to use the following data here to first make a frequency table with 8 classes showing what the class limits are, the class boundaries, the class midpoints, and the frequencies of each class. Then I want you to make a frequency histogram, and then, looking at the histogram, describe the distribution as symmetric, skewed left, skewed right, uniform, or bimodal, and explain the one you picked. Alright, that's it for this lesson. Once again, please make sure to take notes on the entire lesson. Attempt the sponge. Go back to the beginning and put where you think you are on the scale. And take a picture or video of it all, submit it all to Google Classroom, and have a good night.